Welcome to The Explainer. So today we're unpacking the ITPC 510 Artificial Intelligence course syllabus. But honestly, we aren't just going to sit here and read through a dry list of academic requirements. No way. Instead, we're going to transform this document into a practical, step-by-step blueprint for building a functioning, intelligent machine. Think of this explainer as your ultimate guide. We're going to trace exactly how this course takes you from basic, ground-level algorithms all the way to creating systems that can actually perceive, reason, and learn.
Okay, here's our roadmap. We'll start off with the blueprint of an AI, then move into solving problems and searching. After that, we'll cover knowledge, reasoning, and planning, explore how machines actually learn, look at AI in the real world, and finally, we'll prep for passing the final test.
But before we can even start building our digital brain, we have to talk about the prerequisites. Because let's be real, you can't just jump straight into AI. You absolutely need the deep statistical and numerical techniques from engineering math 3 and 4, combined with the structural logic of data structures and analysis. These subjects, they form the very necessary skeleton that our entire AI course is going to sit right on top of.
So, what are the actual stakes here? Well, the grading is split perfectly down the middle. Out of your 100 total marks, 50% is your end semester exam, and the other 50% is dedicated to continuous in-semester assessment. That basically means your ongoing assignments, your midterms, and your practical problem solving, they carry just as much weight as your final test. No pressure, right?
All right, Module 1, the blueprint of an AI.
At the very core of our digital brain is something called the intelligent agent. In this first module, you're going to learn that an AI isn't just some static piece of software sitting quietly on a hard drive. It's an active entity. It constantly perceives the world around it and then acts upon that world to achieve a specific goal. And the kicker, it does all of this based on the concept of rationality, meaning it is literally designed to choose the specific action that maximizes its expected success. Now, whenever you design one of these intelligent agents, you use the PAS framework. This is a total game changer because it forces us to strictly define exactly what our agent is trying to do and how it interacts with its specific environment. PAS stands for Performance Measure, Environment, Actuators, and Sensors. By defining these 4 exact parameters, you clarify how the AI actually measures success, the world it lives in, the tools it uses to act, and exactly how it takes in data. It's just an incredibly powerful way to frame any AI problem.
Moving right along to Module 2, solving problems and searching.
So, there are 2 wildly different ways an AI can actually look for an answer. First, you have uninformed search. Think of this as blind searching, stuff like breadth first or depth first search. The AI methodically checks literally every possible option without any hints whatsoever. But then we have informed search. This is where it gets cool. Here, we give the AI heuristic functions, like an A-star search. These act as little clues, allowing the AI to evaluate which path is likely the best so it can find optimal solutions so much faster.
But it's not all just navigating simple maps. We also have to teach the AI to handle strict constraints and to play adversarial games against actual opponents. You're going to tackle classic logic puzzles, like the water jug problem and graph coloring, using constraint satisfaction. Then, you'll step into the arena of adversarial search. You'll literally design an AI that can play games by looking ahead at an opponent's moves using the min-max algorithm, basically teaching the AI how to playfully outsmart you. And you'll use alpha-beta pruning to save precious processing power, so it doesn't waste time overthinking obviously bad moves. Next up, Modules 3 and 4, knowledge, reasoning, and planning. Okay, here is how the AI actually learns to think. Step 1 is representing facts logically. We use first-order logic for this, so the AI understands basic rules and relationships. Step 2 is where we introduce the messy, unpredictable real world. The AI learns to weigh uncertain probabilities using belief networks and Markov decision processes. And finally, Step 3 is where it all comes together. The AI takes those facts, takes those probabilities, and constructs step-by-step hierarchical plans to achieve complex goals by breaking them down into smaller, manageable subproblems. Now, you might be wondering, why do we need fuzzy logic in this module? Well, because the real world isn't perfectly black and white, right? And our AI absolutely must navigate uncertain information safely. Traditional logic says something is either 100% true or 100% false. But fuzzy logic allows the AI to understand degrees of truth using fuzzy sets. By applying fuzzification and defuzzification, yeah, those are real terms, you can design highly sustainable, adaptable AI controllers that just deal with incomplete knowledge super smoothly. Let's dive in to Module 5, how machines actually learn. You are going to implement some incredibly heavy algorithms here, and they're divided primarily into two camps. First is supervised learning. This is where we hold the AI's hand, guiding it by showing it the correct answers, using neural network models like the perceptron and the backpropagation algorithm. Then we have unsupervised learning. This is where the AI is on its own, discovering hidden patterns in raw data, using things like self-organizing maps. You'll also get a foundational introduction to reinforcement learning, which really rounds out the AI's overall ability to adapt on the fly.
Module 6, AI in the real world.
The syllabus makes sure you aren't just sitting around learning theory. You're going to be looking at expert systems that are operating in healthcare and retail right now, today. You'll study the hardware and problem-solving elements of robotics and dive deep into NLP, or natural language processing. But most importantly, this module covers massive, earth-shaking current trends like explainable AI, responsible AI, and generative AI. This ensures your skills are immediately relevant to today's incredibly fast-paced tech landscape.
Finally, our last section, passing the final test. So here's the real kicker on how you're graded. Half of your continuous assessment relies on solving a unique, real-life problem statement under the direct supervision of your faculty. Out of your 20 continuous assessment marks, a full 10 marks are completely dedicated to this live problem assignment. You have to research, collect resources, and literally design an AI solution right there on the spot. It's a true test of whether you can actually apply these AI techniques practically, rather than just regurgitating memorized facts.
This whole course explicitly targets Program Outcome 11, identifying knowledge gaps and seeking the education to stay current. The field of artificial intelligence moves incredibly fast, faster than almost anything else. So, inspired by the syllabus's own outcome for lifelong learning, you really have to ask yourself, are you ready? Are you ready to take on these 6 demanding modules, push past the complex mathematics, and actually build the intelligent machines of tomorrow? The blueprint is right here in front of you. Now it's time to get to work.